This talk provides some information about how we use DAC2Go to fix some of our broken mechanical testers. We're a service laboratory and we test many materials with small forces and incredibly large forces and everything in between. From time to time, though, what happens is one will quit working, and usually the electronics are broken, but the mechanicals are good. And it's not a surprise, electronics age and fail. We have had also some software issues, and then we've had some where the interface itself to the press was of an old-fashioned type, like these GPIB boards. And then when the computer goes down, you've lost the whole system. These machines are expensive, but they're also expensive to fix, and it has put us in a quandary a few times in the past. The problem is, to fix them, a lot of the documentation is poor, parts are missing, sometimes the problems are intermittent and terrible to find, and there are a few really qualified repair services, and they are expensive. It's very easy to spend $10,000 or more on a service call. The software isn't really much different. It's closed access because vendors really didn't provide much how to do it or how to get into their stuff. It gives them a captive market. And some of the software is kind of old, and the operating systems are ancient, and so the software needs replacing. Occasionally we've had customers that want a different analysis, and we can't even do it with some of the old software. So we've started to use the DAC2Go system integration tool that takes us right around all of those problems and does it in a fairly easy, inexpensive way. Here's how we use it. We basically keep the main part of the instrument, but replace the electronics and software, but incorporate the limit and emergency stop switches. And that way, it turns out to be a safe installation. We also do it in a safe way as we proceed. So one can, of course, just grab the few wires you need and do everything outside the instrument, or you can integrate the whole DAC2Go system and relays and whatever inside the instrument case so it looks just like it always has. This set of examples will show different ways to go about it, because we've done several different kinds of instruments. We've done mechanical ones with and without feedback control, and we've done hydraulic instruments with and without feedback control. They're all slightly different, but they can all readily be done with the DAC2Go mechanical tester system. With a little Instron Mini 44, the servo controller board was bad, and there wasn't any software with it. So we basically used the DAC2Go system with its power modulator and software, and we first off connected it back to a quadrature encoder because the motor was good, and then we graduated to higher performance using a string pot. This is a picture of the whole thing together, where we left all the electronics inside, and we simply brought a barrier strip out the back and connected to the barrier strip. And here it is in operation. You can see the screen right there from the laptop that we use, and it's stretching a spring now. With an Instron 3442, it had different problems. There was no motor, there were bad electronics, and no controller. Now in this case we wanted to really tidy the example, so we removed everything from inside the instrument case, we replaced the dead motor, added a string pot, and then used the DAC2Go hardware and software. So here you can see the machine completely empty. We took out all the old stuff. And on the right side, you can see the overall scheme of what we did. We used a power supply that we fed to the PDR4 power amplifier, and then we have an enable relay and a reverse relay, and then we incorporated the limit switches and an emergency stop and added an extra fuse. Here's what it looks like in place. You can see it all fits inside. The DAC2Go card is over there in the back on the right-hand corner. The power supply is underneath the center, and the relays are spaced nicely still within inside the box. Here you can see it completely finished. It all fit inside the case. Up on the very top you can see the string pot, and we were able to run the cable of the string pot inside the outer case, so it's even protected from anything. When we finished, we put all of the things that we did, all that information on a notes tab in the DAC2Go mechanical tester workbook that's used with that instrument. We also did something similar, a little bit different, but similar, with the Instron 4206. This one has a 2-speed clutch, and of course it goes forward and backwards with a 2-speed clutch. It had the quadrature encoder, and here you can see the main way it looked on the left, although it was broken and static. And on the right we added a board onto which we placed both the DAC2Go, the power supply, and the relays, and connected them up appropriately. Here it is back in service, and you can see we went to a string pot because it gives better data than the quadrature encoder. And so you could place the string pot either up on top or on the bottom. Either one can work out very nicely. And there on the right-hand side, you can just see it in operation. We also added DAC2Go as an upgrade to our concrete testers. We had been using these electronic boxes that just give us the strength at break. But that's not very informative. So we added a DAC2Go and a second pressure transducer and a second string pot so that we could get the complete stress strain curves. And then we had both ways of looking at the sample calibrated by a reference calibration laboratory, 2 different ones, one for each pair of sensors. And then the 2, we did a correlation study with them, and the R-square was 0.9999. Moving on, we also repurposed a 50-ton hydraulic press that we used a string pot for speed control, and so it has servo feedback valves set up along with the string pot and the DAC2Go software. We've even placed the DAC2Go system with a string pot and pressure transducer on our largest press. This one will do a million pounds of force, and it can take a sample 6 feet tall and nearly 4 feet in diameter. On the right you can see some of the data that we're able to look at where we use the comparison tool in the MT software. This is a page shows what the normal user interface looks like, and there are command buttons on the right hand side to do all the common things that people want to do. And it shows real-time meter displays, and then you'll see real-time data being recorded when it's running on the XY graph part. Once the sample's run, it can be exported and so forth. Along with it come a whole group of things. The Mechanical Test Pro software is easy to customize. It's got a number of the common ASTM tests already in place. It's high resolution, much higher than has been previously available, and it has comparison tools that allow people to do things they've never been able to do before with the current software that's on the market. For more information, there are several other videos, and the DAC2Go COM site are good references to see.